Hello viewers, Ronald taking you through the tutorial for A-level pure mathematics. And this video I'm going to go through the topic of loci. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So before we start, let's look at the course outline and check our progress so far. So math paper 1 is divided into 5 parts. The first part is algebra, where 2 questions come in section A and 2 in section B, and these are the topics. The next part is trigonometry, where 1 question comes in section A, 1 in section B, and these are the topics. The third part is geometry, where 1 comes in section A, 1 in section B, and these are the topics. Then the fourth part is vectors, where 1 comes in section A, 1 in section B, and these are the topics. And the last part is calculus, where 3 come in section A and 3 in section B. So what is ticked implies that the video is available on this platform. So the entire calculus was completed, vectors was completed, trigonometry was completed, algebra was completed except complex numbers. Now this half tick means that the video was among the very first videos to be made. Therefore the quality was not very clear, so it will be remade, but it will be remade after the entire topic of geometry has been completed, because the knowledge of all these topics in geometry will be needed in this topic of complex numbers. So now in this video I'm going to go through the topic of loci under geometry. So loci or loci is the plural form of what we call locus. Now what is a locus? A locus is the path taken by a variable point, now this word variable point, according to a set of conditions. So this path is taken following certain instructions, and basically that's all you need to know about loci. The other knowledge you need to know is the one which we covered previously in the previous video of coordinate geometry 1. Therefore you need to know how to get gradient of a line, 2, how to get the distance between 2 points, 3, how to get the distance of a point from a line, and 4, how to get the midpoint of a line joining 2 points, 5, parallel and perpendicular lines, knowledge on those has been known, and lastly ratio theorem in vectors. So when you know that, then you can easily go through this topic of loci. So like I said, the knowledge on the previous topic is what you need, so we shall go straight to the questions. So question 1 came from UNEB 2012 paper 1 question 13 and says, part A, find this equation of the locus of a point which moves such that the distance from point D, which is 5, is thrice its distance from the origin. Like I told you, the locus is the path taken following certain rules. Now here the condition is that the distance of this variable point from point D is thrice the distance from the origin. That means that I have to know the knowledge. I have to have knowledge on how to get the distance between 2 points. So I have 3 points. I have point D, I have point O, which is the origin, this here, and this point which is the variable point. So our variable point will be in form of x, y. It can be either capital letters or small letters, as long as you are consistent. So I'll have to get the distance PD. We're told that this distance from this point to this point is thrice. That is why you see this 3 here. Thrice is distance, so the distance from this point P to the origin. Therefore this statement is very, very vital, and that's what you need to know under loci. So after that, the next it will be the knowledge covered in the previous video of coordinate geometry. So how do we get the distance between 2 points? If I want to get the distance from point P to point D, I have to get the difference in their x coordinates and square it, plus the distance in their y coordinates, square it, and everything under square root. I believe you are well versed with that formula. Then do the same for PO, distance in the x coordinates, square it, distance in y coordinates, square it, everything under square root. But you have to maintain these 3. The next is to remove the square root by squaring both sides. When I square this side, I also square this side, and I square the entire thing. That is why here you see 9 instead of 3, because when I square the whole of this, 3 squared will become 9. Then this one, the square root will just go away. You remain with x squared plus y squared. That's why you see here 9x squared plus 9y squared. Then here you have to, when I expand this, I'll come up with this. Then when I expand this, I'll come up with this. So next is to simplify and collect like terms. So when I take this one this side, it becomes 8x squared. Take this one this side, it becomes 8y squared. Take this one this side, it becomes positive. Take this one this side, it also becomes positive. Then this and this, add them and take them this side, it becomes negative. So that was part A, and that would be the locus they wanted. So now we shall go to part B. Part B says the line y equal to mx intersects, this word intersects, the curve this. So now here you need to know the knowledge of intersection of a line and a curve. Intersects the curve this at points A and B. Find the equation of the locus of point P which divides AB in the ratio 2:5. So here we have to first look for the coordinates of these 2 points A and B. Then we can talk about this condition of the ratio. That's why I told you that you need knowledge on ratio theorem. So at the points of intersection, this is the equation of the curve, and we'll equate it to the equation of the line. When I rearrange, I'll come up with that. Now here x is common, pull it out, you can remain with this in the brackets. Therefore either this is equal to 0 or the whole of this is equal to 0. Now when the whole of this is equal to 0, you'll come up with x being equal to 1 plus m equal over 2. So when x is equal to 0, you remember our equation of the line was y equal to mx, therefore it will become m times 0, which is 0. What about when x is equal to this? Come and substitute for where there is x to come up with this. That means that point A is 0, 0 and point B is this, because they told us they intersect at 2 points. So one point will be this, another point will be this. So now I have 3 points. Next is to remember this condition of the next condition of the ratios. They told us that the P divides AB in the ratio 2:5. That means that AP to PB is equal to 2:5. Therefore, we shall come and quote this ratio. Then we try to rearrange using ratio theorem. As long as these two are the same, you can say that AP is equal to 2, which is this corresponding ratio, over the total. Total is 2 plus 5, which is 7, multiplied by from here up to here, which is AB. That's why you see here AB at that point. So when I cross multiply, I come up with this, and therefore this one in vector form it is that, and this in vector form it is that. So bring this one inside. This one affects both up and down, and this one also affects both rows. So that means that 7x is equal to this. Equating the first row, I'll come up with this. Then when I equate the second row, I'll come up with this. Now the locus means that you have to eliminate the m, or the unknown. So the unknown was m. The good thing we saw that m here is equal to this. So what I'm going to do, I'll come and put it here and also put it here to come up with this. Then when I open brackets and I simplify, I'll come up with that as the locus. So now we shall go to question 2, which came from UNEB 2008 paper 1 question 5, and says, given the points O, which is 0 0, and P, which is 4 2, A is the locus of the points of the point such that OA to AP is equal to 1 to 2. Q is the midpoint of AP. Find the locus in its simplest form. So let A, remember, like I told you, the variable point is usually denoted in terms of x, y. It can be capital letter or small letter. Since we have two, we shall use one will be small lowercase letter, another one will be uppercase. So Q is the midpoint of AP. The good thing, we know P, and we have said that A is that. Therefore, it means that the x-coordinate of Q will be the average of these two, this and this, over 2 to come up with this. Therefore, when I make small x the subject, it will come up with this. Then the y-coordinate, this plus this over 2 will give you capital Y. And when I make small y the subject, it will come up with this. But I already know from this given ratio that OA to AP is equal to 1 to 2, meaning that OA over AP is equal to 1 over 2. Cross multiply, I'll come up with that. Now next is to substitute, get this distance OA and also this AP, distance AP. The good thing, I already have all those points. I have point O, I have point A, I have point P. Now you may wonder why I'm making small x the subject instead of capital X. It is because it depends on what they want. Now here, if you look at this locus, they want the locus of Q, and Q is in capital letters, meaning that you have to eliminate this one, which is small letter. That's why I'm making it the subject, so that after I will be able to eliminate and remain with only capital letter. So that is how you know what to make the subject. So I have to substitute the distance OA is given by this formula, I believe you know it, and distance AP is that. Then this 2 is maintained. You saw it previously, therefore I'll now, like I told you, I have to eliminate the small letters, so I have to remember that small x is equal to this and small y is equal to this. Then I'll come and substitute for small x and small y to come up with that. Now after that, next is to simplify and come up with the equation they want. So when I simplify, I'll come up with that. So here I'm squaring both sides. That's why here it was 2 and now here it is 4, because I've squared both sides to remove the square root. And I've also expanded this. This one was expanded from here, and this one now is expanded from here. So when I simplify this one, open this bracket, I'll come up with this line on this side. This one I've just removed this bracket to remain with only this inside. So next is to collect like terms. So when I collect like terms, I'll come up with this. Reduce this equation by dividing throughout by 4, you'll come up with this. And that is the equation of the circle, that is the locus they wanted. So question 3 came from UNEB 2007 paper 1 question 7 and says, find the locus of the point P, which is xy, which moves such that its distance from point S is equal to its distance from the fixed line x equal to 3. Now here we need knowledge of how to get distance between 2 points and also how to get the distance of a point from a line. Therefore, the easiest way is to make a simple sketch for us to easily know how the calculation comes about. So you shall have the axis, then you shall put point S, which is here, then also put this point, which is here, then you also put this fixed line x equal to 3. Now the distance of a point from a line must be perpendicular distance. I think I already told you that in the previous video. Now they told us the distance is equal. That is why you see here 2 lines and 2 lines to show that this distance from here to here is equal to from here to here. So this is the condition we can get from this question. Now distance SP is the same as distance from between 2 points and given by this formula. Now distance PQ, if you look at this, this is entirely horizontal, meaning that the y coordinate does not change. It is only the x coordinate which changes. Therefore, we shall just get the difference. Here is 3 and here is x. Therefore, I'll come and subtract. So that is why you see here 3 minus x to get the distance from here up to here. When I square both sides, I'll come up with that, and then expand, I'll come up with that, and simplify to come up with that, rearrange to get that equation which they wanted. So that is the locus they wanted. So question 4 came from UNEB 2002 paper 1 question 4 and says the points R, which is 20, and P, which is 30, lie on the x-axis, and Q, which is 0, negative y, small y, lies on the y-axis. The perpendicular from the origin to RQ meets PQ at point S, which is capital X, capital negative Y. Determine the locus of S in terms of X and Y in capital letters. So here the best thing to do is to first make a sketch of what is given. So shall draw the axes, x, y axis and y axis, and label them. So these axes have to be labeled. So this is the origin O. They told us there is point R, which is 20, so shall come and plot R, which is 20. Then point P, which is 30, so shall come and plot point P, which is 30. And point Q, which is 0, negative y, so shall come and plot it 0, negative y. Then they say that the perpendicular from the origin to RQ, so you have to draw line RQ, which is that, meets PQ, so you have to also draw line PQ, which is that, at point S. So we are going to draw perpendicular from the origin to RQ. Therefore, you shall come and draw that perpendicular line. And they said it meets PQ at point S, that is point S. Then they said determine the locus of S in terms of X and Y. So you come and say that for perpendicular lines, you already know that the product of their gradients is equal to negative 1. Therefore, line RQ and line OS, when you multiply their gradients, you'll be able to come up with negative 1. So I'll come and get the gradient of RQ because I already have 2 points. I have this point, I have this point. Therefore, I can get this gradient change in Y over change in X. Then also for OS, I have these 2 points. Therefore, I can get this gradient change in Y over change in X equal to negative 1. When I simplify, I'll come up with that. So this gives me that, and this gives me that. Therefore, small y is equal to capital X over capital X over capital Y. So here we are case sensitive. So shall call that equation 1. That was for perpendicular lines. What about for a straight line? For a straight line, gradient is the same using any pair of points. So here when I use point P and Q, and also when I use points P and S, the gradients must be the same. That is why I'll equate them. Therefore, I'll come and get the gradient using points P and Q, and also gradient using points P and S. Then I simplify and make y the subject. Now I have 2 small y's. Equation 1 was expressed in terms of small y, and also this one was expressed in terms of small y. And our aim is to eliminate that small y. So when I equate the two, small y will be eliminated, and next is to rearrange and get the required locus. And that's what they wanted. So now we shall go to question 5, which came from UNEB 2000 paper 1 question 11a, and says a point P is twice, know this word, twice as far from the line x plus y equal to 5 as from the point 3, 0. Find the locus of point P. So we also make our sketch to ease the calculation. So we shall draw the axes. Then we also draw this line. The intercepts are these ones, 5, 5. Then we shall also show this point 3, 0. That is the variable point which is xy. Therefore, the distance from R P and the distance from P2, they told us the distance of a point is twice as far from the line this as from the point this. What does that mean? It implies that P2, this P2 is twice PR. So the good thing, we already know how to get the distance of a point from a line, which is this formula. I think you remember what we do. Get this point and substitute here in the x, get this y coordinate, substitute here, and you'll be able to come up with this for the numerator. Then for the denominator, look at the quotient of x and put it here, square it, quotient of y, square it, everything under square root. Then this PR is the distance between 2 points. So use this formula, changing x squared plus changing y squared, everything under square root, but you have to maintain this 2. Then you shall square both sides. When you square both sides, we'll come up with that. Then next is to also cross multiply. This one goes this side, and expand to come up with that. And lastly is to collect like terms to come up with this as the required locus. Then question 6 says P is a point on the line, on a line of length 12 units, which moves so that its ends lie on the axis. Find the locus of P when it's the midpoint on the line. So they want you to find the locus of the midpoint of that line. So shall also make a sketch for that. Draw the axes, x-axis and y-axis, and they have to be labeled. Then shall draw that line. So this is the point when it meets the y-axis, and this is the point when it meets the x-axis. So this will be 0, 0, y, and this will be 0, x, 0. But they told us it is of 12 units, and they told us that this P is the midpoint. That is why here this side takes 6 and this side takes 6. But our interest is the whole of this length, which is 12 units. Therefore, we shall come and say that for the midpoint, this one, the x coordinate is got by getting the average of these two x coordinates, which is here, and the y coordinate is got by getting the average of these two y coordinates, which is there. So that means that when I make capital X the subject here, capital X will be equal to 2x. Then here, when I make capital Y the subject, capital Y will be equal to 2y. Now, why am I making capital letters the subject? It's because of this value. If you look at this locus, which they want, the x and y values are in lower case. Therefore, it means that you have to eliminate the upper case. That is why I have to make them the subject, so that at the end I'll be able to eliminate them. So you come up that by Pythagoras theorem, OR from here tier plus OQ from here tier is equal to this, but this should be squared. OR squared plus OQ squared is equal to QR squared. That is Pythagoras theorem. So the distance from here tier, the y coordinates are the same, meaning that the distance is the difference in the two x coordinates, which is x squared. Then also from here tier it is y squared, and from here tier it is 12 squared. But remember, our locus must be in lower case. Therefore, what we shall do, we shall come here and replace capital X with 2x and also capital Y with 2y. When you do that, we shall come up with this. You can choose to reduce to come up with this as the required locus. Then now we shall go to question 7, which says that find the locus of the point which moves so that the sum of the squares of its distances, know that word, the sum of the squares of its distances from the lines x plus y equal to 0 and x minus y equal to 0 is 4 units. So still we shall make our sketch to ease the calculation. So we have the x and y axis. Then we shall draw these lines. One will be this one with a negative gradient, and also this one with a positive gradient, and passes through the origin. Then we shall put our variable point end somewhere. Now we are using capital letters because if you look at these lines, they are in small letters, so they have to be distinguished. Then I'll get the distance of this from here to here. Remember, it has to be perpendicular. I think remember that under coordinate geometry 1. Then from this point to this line, the distance will be that. But they told us the sum of the squares of its distance from this line. So I have to get this distance, square it, and also this distance, square it, and equate it to 4, which is here in the question. Therefore, I'll come and say that QP squared plus PR squared is equal to 4. Now the next is to get distance QP. I think remember that distance of a point from a line, we use this formula. So QP, we are using this equation, so get this and put there this x coordinate to come up with this, put there this y coordinate to come up with this. Then denominator, coefficient of x is 1, that is why you see a 1 squared, and here coefficient of y is negative 1, that's why you see negative 1 squared. Do the same for this line and you'll come up with this, but remember they have to be squared. So when the square affects both the numerator and denominator, so denominator here would have been root 2, but because of the square it becomes 2. Also here it would have been root 2, but because of the square it becomes 2. Then this one is the whole of this squared, and this one is the whole of this squared. So when I take this to this side, or when I multiply through by the LCM, I'll come up with this line. Then expand this to come up with this, expand this to come up with that. Simplify, you'll be able to come up with that, and you can choose to reduce to come up with this as the required equation of the locus. So now we shall go to question 8, which says A is the point 1, 0, B is the point 2, 0, and O is the origin. A point P moves so that the angle BPO is at right angle, and Q is the midpoint of a P. What is the locus of Q? So still we shall need an illustration, so we shall draw the x and y axis. Then we shall locate this point 1, 0, which is there. Then locate this point 2, 0, which is there. Then locate the variable point, which is P, capital X, capital Y. Now they said angle BPO is at right angle. So this is BPO. That angle must be a right angle. That is why you see this symbol to denote 90 degrees. And they want the locus of the midpoint of Q, which is the midpoint of AP. So this is point A. That means that I have to draw a line from here to here and get the midpoint of that line. So I'll come and draw that line, and that will be the locus. So here, if this is capital X, capital Y, here it should be small x, small y. It is okay if you interchange, as long as you don't mix them up. If this one is uppercase, this should be lowercase, and if this is lowercase, this should be uppercase. Any is okay. So the midpoint Q, which is this, will be got by the average of the x coordinates of this, which is that, and average of the y coordinates of this, which is that. So that implies that capital X here is equal to this, and capital Y here is equal to that. Now we are using capital X, capital Y, the subject, because in the question they want the locus of Q. And if you look at the locus of Q here, the X and Y values are in lowercase. That is why you have to make capital X the subject so that we can easily eliminate it. So you shall come and say that for perpendicular lines, the product of their gradients must be equal to -1. That means that this line OP and this line BP, the product of their gradients is equal to -1. So gradient of OP is this, gradient of BP is this, equal to -1. So I'll come and simplify and come up with this. So, but remember, the locus must be in lowercase. Therefore, we shall come and recall that capital X is this and capital Y is that. So That means that where there is capital Y, I'll replace it with this, and where there is capital X, I'll replace it with that. Then when I simplify, I'll come up with that. Open brackets, come up with that. Collect like terms to come up with that as the locus which is required. Then question 9 says variable lines through the points O, which is the origin, and A, which is 2, 0, intersect at right angles. Know that word, right angles, at the point P. Show that the locus of the midpoint of OP is this. So we shall come and first make a sketch to illustrate the given information. So we have the x-axis and y-axis, they have to be labeled. Then this origin is here, and this point 2, 0 is there. We shall put our variable point here, xy. Now using capital letters because the given equation was in lowercase. So OP is that and PA is that. And this is perpendicular, because they say they intersect at right angles. Now they want the midpoint of OP, which is here, and this is the locus they want. So still we shall do the same. The locus, the midpoint there, will be equal by average of the x coordinates to give you that, average of the y coordinates to give you that. Therefore, capital X will be this and capital Y will be that. So we are making capital Y and capital X the subject because the locus they want is in lowercase. So we shall come and say that for perpendicular lines, their product of their gradients is equal to -1. So gradient of OP is that, gradient of PA is that, equal to -1. Then simplify, correct like terms, and now we should remember that capital X is this and capital Y is that. So we shall come and substitute to come up with lowercase letters. Therefore, expand, simplify, then you'll be able to come up with this. But remember, they want you to express the given locus, the required locus, in this form. So what we do shall come, and these two terms we shall factorize out x to come up with this as required. Then question 10 says M and N are points on the axis, and the line MN passes through the point 2. P is a variable point which moves so that the midpoint of the line joining P to the origin is the midpoint of MN. Find the locus of point P. So still here it is easier if you illustrate. So we shall draw our axes and label them. Then we shall come and put this point M on the x-axis and point N on the y-axis. Then we shall draw that line and to pass through this point 3, 2. That is the origin, and this is the point P, which is variable. Now they said the midpoint, these two lines share the same midpoint. That is why they told us that the variable point which moves so that the midpoint of the line joining P to the origin is the midpoint of MN. So they share the same midpoint too. Therefore, you come and say that midpoint of NM is equal to the midpoint of OP. So when I use NM, the midpoint will be the average of the x and y coordinates, and also when I use OP, the midpoint will be the average of their coordinates. Therefore, when I equate this to this, here it has to be a comma. So when I equate the two, I'll come up with this, and when I equate these two, I'll come up with this. Therefore, we shall come out that a straight line has a constant gradient. Therefore, when I use points NM and when I use points RM, the gradients must be the same. So I'll come and get the gradient using NM, which is this, gradient using RM, which is that. When I cross multiply, I'll come up with that. Simplify. Then I remember that capital X is equal to small x and capital Y is equal to small y. Therefore, I'll just come and replace, and this will be the required locus. Then question 11 says, find the locus of point P, which is xy, which moves such that its distance from the point A, which is 5, 3, is equal to twice its distance from line x equal to 3, x equal to 2. So still I'll need an illustration to easily get the calculation. So I'll draw my axes, then put point A, which is 5, 3, and point P, which is xy, join the two. Then also draw this fixed line, which is x equal to 2, and get this. So this distance here and this distance are the ones of interest, because they told us the distance of this point from this, which is distance AP, is equal to twice the distance from line x equal to 2. Therefore, AP is equal to 2MP. So I'll come and use the formula. This is the distance between 2 points, and this is the distance of a line from a point. Now, because these ones share the same y coordinates, that's why the distance is got by subtracting the two x values. So the order matters, because this value here is be greater than this here, the x coordinates. When I square both sides, I'll come up with that. Then square again this one, come up with this. Then collect like terms to come up with that. Then question 12 says, a straight line LM of length 4 units moves with L on the line y equal to x and M on the line on the x-axis. Find the locus of the midpoint of LM. So you shall also need an illustration. So those are the axes. We'll draw them and label them. That's the origin, and that's the line y equal to x. It passes through the origin. Then this is point M, and this is point L, and this is the variable point we want. Now here I'll realize that we are using LYY because here this point lies on this line, and this line set is y equal to x, meaning that the x and y coordinates must be the same. It can be 2, 2, 1, 1, 3, 3 like that. That's why I'm choosing to use yy. Now we can't use xx because you already have here x. So if I use xx, it will be, they will collide, these two values will collide. So I come and say that the midpoint P is given by the average of these two x coordinates and also these two y coordinates. So that means that this y, equate this to this, gives you that, and implying that small y is equal to capital Y. Now I'm making small y the subject because the locus I want is in capital letters, meaning that I'll have to eliminate the small letters. That is why I have to make small y the subject, and also I have to make small x the subject. And when I make it the subject, I'll come up with this. Now here you realize that here we still have small y here, therefore we have to go back and remember that small y is equal to 2y, to capital Y. Therefore I'll be able to come up with x being equal to 2 capital X minus 2 capital Y. Now given this, that LM is equal to 4, we are given the question, the distance between 2 points is given by that, and is equal to 4. Then square both sides. Then simplify, you'll be able to come up with that. But we already know that small y is equal to 2 capital Y and small x is equal to 2 capital X minus 2 capital Y. Therefore, we shall come and substitute. Simplify. Collect like terms. And then try to reduce to come up with that. Then question 13 says, a straight line LM meets the x-axis in M and the line y equal to x in L and passes through the point 6, 4. What is the locus of the midpoint of LM? So this is somewhat similar to the one we have done. So you also draw a sketch, then you put the origin there and draw that line y equal to x. Then you put point M, which is x0, and yl, which is that. Then the point Q, which is that, and this variable point. So midpoint P is given by the average of these two, which is that. So like we did before, small y be equal to capital Y. What about capital X will be that, therefore I have to make small x the subject. But I already know that small y is equal to 2 capital Y, therefore small x is equal to this, as we saw before. So we know that a straight line has a constant gradient, therefore gradient using points LM is equal to gradient using points QM. So when I get the gradient using LM is that, using QM is that. Cross multiply and open brackets and simplify to come up with that. Therefore I have to recall that small y is this and small x is that. Therefore I come back and substitute for small x and small y. Simplify, get that, reduce to come up with that as the required locus. So now we shall go to question 14, which says a line parallel to the y-axis meets the curve this at point P and the line this at Q. Find the locus of the midpoint PQ. So point P lies on the curve this. That implies that the coordinates of P will be x squared, because it would have been xy, but we already know that y is equal to this. Therefore instead of putting y, I'll put the x squared. What about point Q? Point Q lies on this line, meaning that it will be x plus 2. So it would have been xy, but we already know that y is equal to this, so we shall replace it to give you that. So one may be wondering why we're using same case xx. It is because they told us the line is parallel to the y-axis, meaning that the x coordinates will be the same. So let us make a sketch that so that you can easily know why these two coordinates are the same. So we shall come and draw the axes, x-axis and y-axis. So this is the curve, and in this form passing through the origin. Then this one, it passes through the point, the y-intercept is 2. That is why it doesn't pass through the origin. Then we have a line which is parallel to the y-axis, and this is that. So these 2 points P and Q are on that line, and also the midpoint, their midpoint is on that line. Therefore come and say that the midpoint of PQ is given by this. Therefore this is equal to this, will come up with this, and this is equal to this, will come up with this. Cross multiply here, I'll come up with that. But I already know that capital X is equal to X. That means that where there is small x, I'll put there capital X to come up with this locus, which is in uppercase letters. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on circles. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on circles has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that they can all benefit as a family.